I'll just point out that in the PowerPoint that you already have, you have the slides for the additional scenarios for Burkina Faso. So you can go through the slides. Maybe between now and tomorrow's meeting, you could go through the slides. There are several additional scenarios, including doing it for routine immunization, and then doing sample size for classification instead of estimation. So look at the video, look at the slides, and then if there are questions, we can talk about them tomorrow. We can provide additional materials if there are still questions. And then I'll look through. I see that there are some more great questions in the chat here. I'll look through those and type something up. Someone's saying, oh, hey, we need to have a spreadsheet that allows coverage below 50%. So we can tell you how to use this spreadsheet to handle that, Michael, or we can also just change the spreadsheet so that it works below 50%. That's a great question. So I think some of the questions, right, like can one team cover more than one cluster per day? That depends on a number of things. So some of these questions here are going to be covered later in the course, and some of the questions are relevant for the sample size. So I guess we'll just spend, for those who can stay, I'll go ahead and look at the next scenario. But if you can't stay, we've only allocated this hour, then you can go through the additional slides. And as I said, I'll be posting, we'll post an update with a few new videos also that talk about why are we using the numbers that we're using in the methods that we're using in this manual instead of some methods that you might have used elsewhere. So if you need to go now, go ahead and sign off. And if you can stay, then we'll look at these, we'll look quickly at these additional scenarios in the slides.
And just to, as a reminder, thank you, Dale. As a reminder, you do have an assignment due at the end of this week in which the Ministry of Health of Harmonia is asking you to perform a sample size calculation, and you're being asked to also to evaluate the sample size that comes out of the parameters that the committee has selected. So this will be a practical way for you to apply what Dale has been working through. In addition, of course, some of these questions probably require more pondered, a little bit of thought to respond. So we'll be sharing the questions and Dale's answered in a more structured way between tomorrow's discussion group and probably in a follow-up update as well, once he's had a chance to review these, all of the questions that you've shared, including some that may not have been explicitly answered. So yes, Dale, back to you, and please do go ahead.
Great, thanks. Thanks for the comment here about the formula. I'm sorry if this is confusing. These bars, maybe we should find a clearer way to do this. This formula is B times C divided by M. But so these horizontal bars, they do not mean divide by. This is a space for you to write in the value of B. And this is a space for you to write in the value of C. And this is a space for you to write in the value of M. So if this space makes it look like we should divide by something, then I apologize. And I'd love to have, if you have some suggestions, if you want to email me back with a different way to show it. We want it to be a worksheet, so we want there to be a space to write it. That's what the horizontal bars are here. So whenever there's any division in this worksheet, there's a slash to indicate division, not a horizontal bar. So these are spaces. The horizontal bars represent a space to write the number, and then the equation goes across. So again, this is D times E times M, A times number of clusters per stratum. So thank you for that comment. Okay, so picking up with this next scenario, they're saying, can we also add a routine immunization survey here? Well, then we have to decide, if we're going to entertain that suggestion, we have to decide, okay, we can probably do that, but who is going to drive the sample size calculation? Are we going to base the calculation on wanting to have precision for the post-campaign result among children 9 months to 15 years? And if so, then probably M remains 10. then maybe adding the RI survey, it doesn't change the sample size required. And but it means probably we will only have maybe 2 respondents per cluster that would fill out the RI survey, and everyone else would just be filling out the SIA survey. And but if we change the main outcome to be Penta 3 coverage, then that changes a lot of the numbers, and we need to redo the calculation. So that's sample size scenario 3. If the main outcome is Penta 3 coverage, well, now Penta 3 coverage is not so high as 95%. Let's say it's 80%. And we say that we still want a confidence interval no wider than plus or minus 5%. And now our age range is only a 1-year window. So instead of finding a respondent in every household, the people in Burkina Faso tell us, the people at the census office tell us, no, you're probably going to have to visit 5 homes. Every 5th door that you knock on, maybe we'll have a child that's the appropriate age. And maybe we say, okay, well, we want to have 10 RI responses per cluster because we want to have good precision, probably at the district level. Also, this is at the district level, no wider than plus or minus 5% at the district level. So let's go for 10 completed RI responses and maybe 10 completed SIA responses. And again, 5% of respondents not home or refuse. Well, then the next few slides help us find our effective sample size. So now our effective sample size, when you go from 95% down to 80%, the effective sample size gets bigger. It goes from 162 to 306. So that's the value of B. It's going to be 306. We'll see it in the table in a moment. If you switch from doing an SIA survey to a routine immunization survey, the ICC is usually higher. So now we go from an ICC of 1/6 to 1/3. So the design effect goes from 2.5 up to 4. And so this is our new table of inputs. Inflation factor E here stays the same. We're still going to 63 strata. In each strata, if we did a simple random sample, we'd be looking for 306 completed responses. We have to inflate that by a factor of 4. We have to go to 5 households to find an eligible RI respondent. So now, instead of needing 25,000 responses, in order to do this survey, we would be looking for 77,000 completed RI responses. And we would be going to 7,700 clusters. This is a huge endeavor. We'd be going to 53 clusters. Let's see, 123 clusters in every district. That's a huge effort. And here it is typed into the, you don't see the inputs up above, but here's the bottom of the spreadsheet where we're now comparing these 3 scenarios. And again, for these scenarios, I used 1.05 for the inflation factor. So now we say, let's classify coverage instead of estimating. Let's accept more, less precision at the district level, and we will classify coverage at the district level. We'll have confidence intervals that are perhaps wide, but if coverage is very good, or if coverage is very bad, then we will confidently classify coverage as being high or low at the district level, and we will aggregate the data from the districts to estimate coverage at the administrative regions and at the national level, and those estimates will be quite precise. Well, we need a different set of inputs for classification. For classification, so we're saying that the main outcome is Penta 3 coverage. Again, it's 12 to 23-month-olds. Here, I've switched the target coverage to 85%. I didn't mean for those to be different, but this was the figure we actually used in Burkina Faso. And then for classifying, we say we need to pick another coverage threshold. We say if true coverage is below 70%, well, then we want to have a high likelihood that those districts would be classified as fail. When I say, we skipped the slides on what do we mean by classification earlier, and so you should look at that movie. But when I say classify, I mean that we're going to apply a label to each district. We're going to estimate the coverage there, and we're going to use a one-sided confidence bound to apply a label like pass or fail or intermediate. And in this case, we're saying if true coverage is below 70% for Penta 3, we want to have a high likelihood, an 80% likelihood, that the classification would fail that district. So you'll see in the video that talks about it, delta then, the difference between these two coverage levels, 85 to 70%, delta is 15%. This is a number you need to look in the table. And the direction is below. So now we're talking about the statistical power. We're defining the power below. So now the earlier question is relevant. We want to have 80% power to fail the district when the true coverage is below 70%. And what are we going to use to classify the district? We're going to use one-sided 95% confidence intervals. So because it's 95%, alpha is 5%. So now instead of using table B1, we're going to use table B2. And I haven't shown you the whole thing because it takes up a whole page. I've just shown you the relevant section here. But this is table B2. We want to classify coverage as being very likely to be below the programmatic threshold. Alpha of 5%, power of 80%. And we want to specify our power when the true coverage is 15 points below 85%. So delta is 15. So we find here, oh, wow. The effective sample size is 49. Remember, a minute ago, the effective sample size was much bigger. What was it? It was 306. So now this survey, it's 49. That's 1/6 of the size. We're going to cut the survey size down by a factor of 6. So the new effective sample size is 49. Everything else, the design effect is 2.5 because I also changed, what did we also do? We changed the ICC. So they said based on some recent survey, 1/3 is too conservative. Let's use 1/6 for the ICC. Sometimes I buy that argument and sometimes I don't, but if we use 1/6, then the design effect goes back to 2.5. And then we can use these formulas again. So now we're looking for a sample size of only 7,000. We have to go to 40,000 households to get 7,700 respondents. And that's because we have to go to 5 households for each respondent. And some of them are going to refuse to participate. And we're looking at going to 819 clusters overall, 13 clusters per stratum. 13 clusters per stratum sounds doable to me. In fact, if anything, it sounds a little low. Usually we like to go to more than 15 for classifying. So we're back maybe in the realm of something that's doable here. Okay, so we can enter this scenario into the spreadsheet. Here we would use the spreadsheet called classification. Enter these values in there and you'll reproduce the numbers. If you can't enter this, if this cell is locked, then you can enter 0.95 in the response rate or in the participation rate, and you'll get numbers that are very close to mine. And in this next scenario, what we say is that we're going to classify not routine immunization, but here we're going to classify the SIA coverage. So again, the target coverage was 95%. And we say if true coverage is below, let's say 87%, then we want to have a high probability that we would fail them on their SIA coverage. So delta is this minus this. It's 8%, direction is below. We want 80% power to fail them, so beta is 20%. So we're going to go back into table. I didn't show you the table. I just typed the numbers into Dana's spreadsheet. And we get numbers here. So this response is for classifying the routine immunization coverage. This scenario is for classifying the SIA coverage. Here, this is saying that we would go to 20 clusters per stratum. We would go to a total of 1,260 clusters. We'd be looking for a sample size of around 12,000. So if you did this survey, you would also have plenty of power to do this classification as well, because these numbers are bigger than this number. So what happened in the end, in real life, Burkina Faso did decide that it was a high priority to have RI results from each district. And they wanted to have about 10 completed RI responses per cluster. This required going to 50 homes per cluster and 20 clusters per district. That should yield about 50 responses. If we asked in every home, if we asked kids who were eligible for the SIA, well, that would have given us 50 responses per cluster for kids eligible for the SIA. And remember, I said before, we don't usually like to, it's a waste of time to collect usually more than about 15. So we used a trick where in the survey, there was a random number generator. Every house we went to, only in 1/4 of the houses did we ask the questions for SIA respondents. So 1/4 of 50 is 12.5. So every 12 or 13 houses in each cluster, we ask the SIA questions. And in every house, if there was a child eligible for the routine immunization survey, we administered that questionnaire to those kids. Maybe I'll share a link with you later in the week too. We have a YouTube movie that shows how the data collection was rolled out across the country, how many days it took to collect the data in the survey. So the Ministry of Health, they would have liked to have very precise Penta 3 estimates in every district, but it would have been too expensive. And so they compromised on being able to classify coverage as a fail when the coverage was below 70%. But then they were encouraged by the fact that we could aggregate the data across districts and make precise estimates at the regional level and the national levels. So the organization that fielded this survey, they chose to field 63 data collection teams, one to each health district, and they used about 256 data collectors. So then you can see that they have a challenge at that point then in how do I do this and also maintain high quality. So then you have to think about the training and how are you going to have consistent performance across 63 teams and 256 data collectors. It's a big survey. And in other situations, the decisions might have differed. You might talk the steering committee or the Ministry of Health out of that and say, no, instead of having 10, instead of visiting 50 households per cluster, let's just visit 10. We'll only get 1 or 2 or maybe 3 routine immunization respondents per cluster. And this won't give us much power to say anything about routine immunization at the district level, but at the national level, we'll have a big sample. 2,520 is a big sample. It's going to give you precise estimation for routine immunization, but the precise part will only come at the national level, not at the district level, and not even at every administrative level. In this situation, they said it was a priority to get the numbers in every district, and so instead of going to 10 households per cluster, we multiplied the workload by 5 and went to 50. So these decisions shake out in different ways for different surveys. Different situations call for different decisions. I saw someone in the questions here asked about lot quality assurance sampling. This manual and this course is not about lot quality assurance sampling. I'd be happy to have a conversation where I tell you all the reasons why a cluster sample with a probability sample is much better for estimating vaccination coverage than lot quality assurance sampling. Lot quality assurance sampling has its place, but this method I think is better for vaccination coverage than LQAS. And if you're an LQAS a person, we can have a conversation about that if there's enough interest in having a separate conversation about LQAS and comparing the classification qualities of this design versus LQAS. So in this, we're always going to do a cluster survey, and we're going to estimate the coverage in every stratum. We'll estimate two-sided confidence interval if we're estimating coverage, and we'll estimate one-sided confidence bounds if we're classifying coverage. And then if the strata are nested and exhaustive, then we can aggregate upward. Or as one of the people pointed out earlier, if you select a random sample of strata, you can also aggregate upward and calculate national coverage estimates. We hope it will become intuitive to you, if it's not already, that the precision improves when you have a bigger sample size. But there's a little bit of a trade-off because the survey quality can be a challenge with a bigger sample size. And then to do your homework this week, you can use paper and pencil. You can use the worksheets in Annex B1, and so we have Mary to thank for those worksheets, or you can use the Excel tool, and we have Dana to thank for those. We recognize that some of you downloaded the first Excel tool that was shared last week. You want to look for the link for the newer tool because it will handle more Strata, and you're going to need to be able to handle more Strata to do your homework this week. And it sounds like perhaps we'll probably release another version of the tool that allows you to type in the inflation factor directly, and one that lets you put in coverage values that are below 50% instead of having to use the trick that we know for doing that. So you can watch for an announcement, but the tool that Red has shared the second time will be sufficient for doing your homework for this week. And we'll continue, based on your feedback and questions, we'll continue to improve the tool and share additional versions.
Great, Dale. Thank you. We have 10 minutes left, so I'd like to suggest we haven't. So we've had many comments and questions. That's really really good. I'd love to hear some of the voices of the participants. If you'd like to react to what you have, what Dale has just walked us through. If you have questions or comments that you'd like to say rather than type in the chat window, you can use the raise hand feature. So you'll see a little raised hand. You click on that, and that allows me to see that you are requesting permission to speak, and then I can unmute your microphone. So I saw a couple of hands raised during the presentations. Okay, so we have a first comment or question. The first hand raised from Talil Ahmed. So Talil, welcome, and we should be able to hear you.
Yeah, good afternoon. Do you hear me now?
Yes.
Yes.
Okay. We have conducted an immunization coverage survey using the revised recommended methodology in 2015, and this time we are using as a baseline to know where we are.
Yes.
But at the end of the year, at the end of the project, we are going to use the same system to know how far we went so to compare.
Yes.
And also during the survey, we have generated a lot of information in the baseline, in the draft report. And there are a lot of information, some of which you can start. At the beginning, the objective was to estimate, but the information you gain will also give you the possibility of comparing
Yes.
Various groups and whether the mother is illiterate or literate, and the factors that drive in whether the child is vaccinated. But sometimes it's very hard to distinguish between the compare and estimate.
Yes.
Not in the sense that has been explained in the manual, and can you advise how we can go about it?
Yes. What country are you talking about?
In Ethiopia and Somali region.
Great. Yes. So there is, in your homework, you won't have to compare. Annex B3, which we didn't talk about today, but Annex B3 is dedicated to the topic of comparing. And comparing is almost never the primary goal of doing a coverage survey. In a few times, in a few places it is, and so we have Annex B3, and we can participate in a conversation about it. But it's very difficult to do that because, you're talking about comparing the coverage change in 1 year. Even if you are amazing supermen and women, how much can coverage possibly change in 1 year? It's going to be a small change. And so we know from statistics that to measure a small change reliably, you have to have a very big study. You have to have a huge study to confidently measure small changes. But there are a few countries. Pakistan is one, and I'm interested to hear that Ethiopia and Somalia also are thinking of doing it. So it's usually not the primary goal for comparing, but if it is, Annex B3, and you'll see also in the spreadsheet, there's a tab called comparison that I didn't mention today, and I didn't provide a scenario. But you can run some numbers through the spreadsheet or through the equations and see the size of the survey that you would need to do if you want to compare coverage, if you want to design two surveys to detect a change in coverage. When we get to Module 3, which will be some time from now, when we get to Module 3, we will talk about, you mentioned comparing coverage, for instance, among literate women and illiterate women, the caregivers of the children. We will talk about how to do those comparisons. So just because it's not usually the primary goal of the survey to compare doesn't mean that we don't do some comparison in the analysis. So we will, in Module 3, do some comparison among groups like that. But it would be rare to say that the primary goal of the survey is to compare coverage from literate and illiterate women, and to select a sample size based on that.
Yeah,
but
and the primary purpose for us was only to estimate.
Yes.
And the information we generate and the project duration would be 2 years, not 1 year.
Okay, good. So the in some cases, it's done to compare, and when you compare, as it says in Annex B3, if you're going to do a survey and the main goal is comparing, then you have to use a method that is as similar as possible to the previous one, because we want the biases in the two surveys to be very similar, so that any difference we estimate, or as much of the difference as possible, is due to true change in coverage and due to margin of error. And we can control margin of error by using a bigger sample size. But it's very common to want to compare coverage from a new survey to the last mix or the last DHS. And you will never be able to stop the Minister from Health from making that comparison, from pulling the DHS report off his shelf or her shelf and making that comparison. But you have to remind them that these numbers can differ for several reasons, because there are different biases, especially if they use different methods and different teams, then the two surveys will have different biases. That's one source of difference. Each of the two surveys will have different sampling, a different margin of error. That's another source of difference. And then also, perhaps, over time, there has been some improvement or some deterioration of coverage. That's the other source of difference. But we cannot just compare the two numbers and say, with confidence of surveys that were conducted using different methods and teams, that the difference is due to the performance of the health system in the country.
Okay, we have at least two more questions or
Great.
comments. The first one from Hassan Ibrahim, and then I did see one other hand raised that seems to have gone down from Mohammed Imran Qureshi. So let's go to Hassan, and we only have 3 minutes left. So
yes.
Hassan, you'll have to unmute yourself. I've unmuted you, but you also need to unmute yourself in order to be able to speak. Please go ahead and do so. Okay, let's go to Mohammed, and while Hassan is figuring out or solving that technical issue, Mohammed, let's welcome, and please state your question or comment.
Hi everyone, can you hear me?
Yes.
Thank you, Del, for a very, very good presentation on the sample size calculation. My name is Dr. Imran from Punjab, Pakistan. Just want to know that it is quite easy in our field practice to inquire or confirm the status of SIAs in a household rather than to confirm the routine immunization status in that household. So how you adjust the sample size while considering this time window is more in routine immunization coverage as a confirmation rather than in SIA coverage confirmation?
If I understand the question right, I agree with what you said, that it's much easier and faster to ascertain the SIA coverage status than the RI coverage status. And in my opinion, if you're going to add RI to SIA survey, in most situations it makes sense to let the SIA drive the sample size and treat the RI information as additional nice to have information, but not to drive the sample size, because it will quickly take over the whole survey. And it may delay the survey, which will then degrade the quality of your SIA results by adding additional time. So I think it's a rare situation. Burkina Faso was one, but it's a rare situation where you would have SIA would move over and let RI drive the survey. Does that address what you're asking, or did I miss a subtle point?
No, I think you very well answered the question. And secondly, I want to know about this complete health as a survey, like we had Punjab Health Survey as a package, as a whole health, with a bigger questionnaire, in comparison to a survey which is just inquiring either the SIA status or it is just combined with routine immunization. So how much the quality of that survey is affected in terms of true reflection of EPI coverage once you are holding it along with other health programs and other health domains?
That's a great question. People often ask, the same thing is true for a DHS or a mix. So many modules, you gain so much insight into so many areas of health and demographics. It's a super valuable vehicle for adding questions, but then for each topic area, if you're part of a 2 or 3 hour interview with the caregiver, it's a challenge to maintain high quality for numerous modules in a long interview. And so does the quality of the vaccination survey, of the vaccination, the fact that it's a long questionnaire might mean that the quality is degraded somewhat. But the fact that it is a big survey with a lot of resources, and sometimes, for training, I know in the recent mixed survey in Nigeria, the workers were trained not for 1 day, not for 1 week, they were trained for 1 month before they are sent to the field. And so this has the effect of improving the quality, we hope, because there are a lot of resources, and we can try to fight the effects of the long questionnaire by stressing the important topics in the longer training. So it is a tension. Usually, if you have one topic that you care about the most, it's good to practice the art of saying no when your colleagues ask if they can add some questions to your survey. You can say no with a smile, but it's usually the right idea to say no when they ask to add questions to your survey. But it's not always possible to say no.
Okay, thank you, Dale. We're technically out of time. We're already 1 minute over time, and we do want to keep these sessions tight. Thank you, all of you, and first of all, Dale, of course, these many subject matter experts who've also joined this session, and all of the participants for your participation and attention. We do have more questions, but given that we have a discussion group tomorrow, I would suggest that we table these questions until tomorrow, if that's okay. Let me just unmute Carolina. I know you. Are there any specific questions that you'd like to highlight in terms of the what's been posted in the chat, or any final comments or words for the participants?
I think for the sake of time, thank you very much. There are a couple of questions that I don't think were addressed yet, so I propose that we do a Q&A to answer the most common questions or the very relevant ones, and post that by the end of the week. And also I really encourage the participants to read the material, think about it. This is not easy necessarily, so don't feel bad if you don't understand it at the first time you read it. Read it again and ask questions to the team through Scholar. Thank you.
Thank you, Carolina. So some of your feedback has come in loud and clear. Thanks to those of you who have already completed the feedback survey. That's much appreciated, and we're aware that in some cases, some of you are reporting spending a lot more time than you expected. We're hoping that if you're doing so, that means you're finding the time spent well worth it. If If you'd like to give a feedback, I'm posting the link to the feedback survey once again, and we'll be reviewing, looking at the feedback from the group tomorrow. Thank you, Dale Rhoda, as well as the other subject matter experts, of course, Carolina, as well as Chesco Nogareda. You've been watching some of his videos about the Malawi vaccination coverage survey. Dove, Josiah, and Felicity Cutts. Felicity Cutts will be with us tomorrow in the discussion group. We have a lot of activities, and you should expect to participate and to contribute. You may be called on to present your week 1 assignment. You may be called on to share your progress on the concept note or on the sample size calculations. I hope that won't scare any of you away. We will be kind and gentle, I believe, as a course team, but tomorrow's session will be about participation, and your participation much more than about lecturing, which is also very important. My suggestion, my recommendation is to go to the Scholar community as soon as you can and look at the videos that Dale Rhoda has prepared to walk you through this process again. We'll make the recording of this session available, and as Carolina said, so there is a learning curve to this particular step, which is why we're dedicating an entire week, 2 weekly assignments, and a significant session of the concept section of the concept note to it. So once again, thank you all, and look forward to seeing you again tomorrow. This is the only week in which we'll have 2 sessions, but after walking through this content, I hope you understand why we made this decision and really appreciate your commitment and dedication and diligence. If you're falling behind, if you need any support, let us know. You can contact me privately or any other member of the course team, and we're really here to support you and ensure that you can get back up to speed. We've seen people catch up even when they've fallen 2 weeks behind. So if you're a couple of assignments or a couple of tasks behind, don't hesitate to reach out to us. Thank you. I'm now going to unmute everyone so we can say goodbye to each other. It's going to make a lot of noise, but that's what having dozens of people from all over the world connected to each other does. Have a pleasant, lovely afternoon, evening, or morning. See you.
Okay, take care.